Hey everyone, welcome back. In the first video, we made an introduction on design patterns. Now we're going to finally dive into those patterns. What is the first pattern we're going to cover? The famous or infamous Singleton Design Pattern. Singleton Design Pattern, maybe one of the easiest patterns, one of the most used, I would dare to say. So what is the Singleton Design Pattern? Singleton Design Pattern is a creational design pattern. It helps us ensure that a class has only one instance. That's new. Typically we instantiate classes, we instantiate more than one object, right? But this time we want only one instance. Since it's only one instance, we also have to provide a single point of access to that instance. As I mentioned, one of the most straightforward patterns widely used in the industry. When do we use that pattern? So here we have, when you want to ensure that a class has only one instance and you want a global access point. What could be a type of instance that you want only one? Here we have examples as database connection, thread pools, configuration settings. There's also logging systems. You want only one managing point. So typically, when you're talking about managing resources or managing some sort of responsibility, we might think of a Singleton Design Pattern. What are the elements and characteristics of Singleton? Finally, we're going to dive into some code soon. So let's just read this and then we dive into the code. So here we have private constructor. Oh, that's new. We haven't seen private constructors yet. So the Singleton class has a private constructor, which means that it cannot be instantiated from outside of that class. Interesting. So by making the constructor private, no other class can create an instance of that class, of the class that we want to instantiate. The responsibility will be within itself. Private instance. So within that class, there's also a private static instance of itself. That's also new. We're referencing the class within itself. This instance is the single instance the pattern ensures. We also have a static method for access, a global point of access. So to provide access to the single instance, a public static method, often named getInstance. It's just a getter, nothing but a getter, just returning the instance. Almost there. A static method is provided in the Singleton class. Note that it's a getter, but it's also responsible for creating the instance if it does not exist. If the instance already exists, we just return that existing instance. As an optional thing, lazy initialization, you might want to initialize the Singleton instance only when it's first created. Typically that's how. We're going to invoke the getInstance method and it instantiates the class when needed. Helps us saving a little bit of resources. Key points. I will navigate to this in a bit. This is the representation of the Singleton design pattern in UML. So we're going to have a sample code first, then we go to a more, let's say, meaningful example. So run Singleton, we have this class, it's going to have our main method just for instantiating the objects. You can see that it's using the Singleton sample class. This is a new notation, a class pointing to itself. What does that mean? Because it does have a reference to itself, as you see right here. Here we have a reference variable named single object of the type Singleton sample. Look at the type of that class. So that's the same type of the class. This is the referencing of itself. Notice that it's also static. Constructor, private constructor here is omitted. We're going to see it in the code. And here you have the getInstance method that returns the instance of Singleton sample. And you, of course, can have any other methods within that class. Let's dive into the code. So let's see what we have here. First one, we have Singleton. So let's expand that beautiful project. So Singleton, source packages. Let me try and zoom in a bit. Here we have Singleton, source packages. First one, sample Singleton. Let's open that one. We have the two files, run singleton and singleton sample, as the diagram. Let's try and zoom in a little bit. So what I'll do, right click, I will run this file. It does have a main method. Interesting. So here's our console output. What happens here? Let's go line by line. So our public static void main method, just as starting the application. So first, we declare a reference variable named singleton of type singleton sample. Then we're going to try and retrieve an instance and also assign it to that little variable. So what do we have here? Singleton sample dot get instance. Okay, so you already know it's a static method. I'm accessing it directly. So I'm not saying new singleton sample, right? Notice that the compiler screams at me. Why is that? Let's see the answer. Singleton sample has private access in singleton sample. Ooh, that's our private constructor, remember? We'll see that. So I will just revert my changes and we'll see that. So for now, let's say it creates the instance, singleton dot worker method. So we're just invoking the method. Does this first print, do what you were designed to do. Then we're trying to instantiate it again or retrieve another instance or the same instance. We don't know what's happening yet. Then we invoke the worker method in the other reference variable object. Then we're just comparing those two objects. We're comparing the object that we created. Singleton is equal to another object. Gives us true, because it is the same. Ooh. Let's see what happens. So if we control click to singleton sample, takes us to that beautiful class. What do we have in this beautiful class? So, as per those slides, we have singleton sample class. We have the private static variable storing the reference. This is going to store the reference to the single instance. So private static, same type of the class, just the name of the variable. Then we have our private constructor. So this is new, we haven't seen this before. So private constructor blocks us from creating instance of singleton sample outside of this class. Then we have the static method that returns the reference to the single object. So here we have a public static method, return type, the one of the class, so singleton sample, because I want to return single object, and the name of the method, typically get instance. What do we do in this highlighted section here? So we typically do this already, so, right? We create. Typically, we already do this, right? We are assigning an instance to the variable. But notice the magic here, our beautiful if statement. So if our variable, our reference variable, single object is null, okay, then I instantiate new singleton sample. Next time I call it, it's going to check, hey, is it null? Is it? Second time is not going to be null, right? Because we already initialize it. So the second time we invoke, this is going to be false. So it's going to skip right to the return statement. And the method returns that instance, that existing instance. Notice that it is a static, right? So every time I call singleton sample that get instance, it's trying to access the same memory location. Here at the bottom, you can see any other extra methods that that class is going to contain. So this is the basic structure of singleton. Why is it a pattern? Because it's going to repeat itself a little bit. So if we go to example B, we have, so I will save this, close and close. Let's take a look at the run singleton database example. So here we have our beautiful main method. Main method, we're going to do the same thing, but now for databases. Remember, databases is one of the examples we gave. for managing resources. We only want one reference, only one place managing database connections. So similar to the example, database variable, we're trying to get instance of the database. Then we invoke the worker method or any method, so trying to get the connection. Oops, I forgot to run, so let's do this. Right click, run, successfully connected to database, successfully connected to database, as you can see it. Get connection invokes it, get connection invokes it. Then we try to comparing those two objects. So here, what do we have inside database? So in database, notice the pattern. We already have a private static same class reference. Then we have our private constructor. So we cannot instantiate this class outside. We cannot instantiate database class outside of itself. Our get instance method with the exact same structure. So a static method that is going to return the instance of, or the variable, the object within the database variable. Name of the method, getting instance. Here line 15, we're instantiating it, and then the magic happening again. If the database is null, so if this reference is null, we instantiate it. That's for the first time. So for the second time, next time we run it, hey, is that reference null? Not anymore. So it just returns the value. Worker methods at the bottom. Right click and run again. It gives the same thing. I did not mention, so it's out of scope. This is not thread safe. So if we're using multi-threading, we might face issues. So you can search some extra literature. It's out of the scope for this time, but stay aware. There might be issues if it's multi-threading. Last Singleton example is the logging. So run logger. What do we have? This is going to be a little bit different. We're not comparing the objects anymore. So what do we have here? Logger gets what? Logger class dot get instance. So there's a static method here. Then from that logger, I'm going to invoke the log method, which takes this argument. Then I'm going to close it. So if I right click, run the file, I see nothing here because this is actually saving to a file. So if I go to files, Singleton, you can see it right here, logger.log. So if I open it, there's a couple of, this is my log, this was done right now. If I close this, it's okay. Let's go to logger. So go inside logger. What is inside logger? Imports public class logger, nice. Okay, here's the pattern happening again. I'm starting to detect it. So we have a private static, same class type, reference variable here. We can have, of course, extra class properties. Our beautiful constructor to prevent external instantiation. Notice that this time we're initializing the log file, not the actual instance, we're initializing the log file within the constructor, so we can perform, again, any operations. Instantiating our print writer, file writer, define the name, and append at the end of the file. Beautiful. So, what do we have next? Our get instance method. So here we have the public static type of the class, return type, name of the method. Line 27, I'm always skipping this, so in this line, it's actually where we instantiate this class. And then we have the magic happening. Hey, is this instance variable null? Yes, it is. If it is, we instantiate the object. Otherwise, so from the second time on, we're just returning that instance. And we have our extra methods in that class. It's still a regular class, it can have extra methods. So here we have the log method. Log method takes a string, getting the timestamp, and I'm printing to the log file, as we've seen in the sample file. And then at the end, of course, we close our resources. We close our I/O. Love it. This is my log. New log. Right click and run. Okay, successful. Let's go to files, logger.log. There you go. This is the one we've just created. Now we can talk about the key points. So based on the code, what do we ensure? Only one instance of the class throughout our application. With the getInstance method, provides a global point of access to that instance. Why is it good? Manages the resources that should have a single point of control. So the database connections, we're not actually connecting to the database yet, but there was an example: thread pulls, logging, configuration settings. Be mindful of multi-threading. I did mention about multi-threading. Synchronization, that's the key word I didn't mention yet. So synchronization or other mechanisms may be necessary to ensure the thread safety.